Hey guys, it's Miss Delito. We're going to take a look today at how we can solve inequalities procedurally, and we'll talk about how we can graph their solutions, and we'll even talk about some special situations where we solve inequalities that deal with negative coefficients and having to change that inequality symbol. So the nice part about solving inequalities is it's the exact same process that we would follow to solve an equation. So we're going to use inverse or opposite operations to isolate the variable. The only difference is that the symbol in this is going to be different. So instead of an equal sign, we're using a less than, greater than or equal to, or less than or equal to. So I can still separate both sides of my inequality by drawing those lines right around the inequality symbol, and we'll start with that same process. So I'll start by subtracting 4 from both sides of the inequality, and I'm left with 2x is greater than or equal to 20. I'm then going to divide both sides by 2, and I'm left with x is greater than or equal to 10. So before I decide that this is officially my solution, I'm going to go through a process of checking to make sure that this actually works. So we can check using any value for x that makes this inequality true. So x has to be greater than or equal to 10. I can check with 10. 10 is greater than or equal to 10. 2 times 10 is 20. 20 plus 4 is 24, which is greater than or equal to 24. I also want to check using something that's greater than 10 to make sure that that piece of it is accurate as well. So 11 is greater than or equal to 10, so I'm going to use that. 2 times 11 is 22. 22 plus 4 is 26, which is greater than or equal to 24. So I know that this solution is in fact correct. When we go to graph our solution, we're going to choose 3 values to put on our number line. 10 must be one of those values. Numbers that are less than 10 go to the left on the number line, and greater than 10 go to the right. So because 10 is included in the possible values for this inequality, we're going to use a closed circle at 10. And all of the values that are possible for x are going to be represented by the direction the arrow is drawn. And because any values greater than or equal to 10 are possible solutions, our arrow is going to point in the direction of all the values that are greater than 10. We can verify this because we used 11 to check, and we know that 11 does in fact work in this situation, and it's included in the solution shown on our graph. We're going to look at example number 2. So same process, we're going to add 3 to both sides. M divided by 2 is less than negative 3. Now I'm going to multiply both sides by 2. So m is less than negative 6. We're going to check again, so we need a value less than negative 6, and in this case, negative 10 is less than negative 6. So negative 10 divided by 2, which is negative 5, and negative 5 minus 3 is negative 8, and negative 8 is in fact less than negative 6. So since we know this is our solution, we can go ahead and graph. So negative 6 must be a value on that graph, and we want to be careful, especially with the negatives. So numbers that are smaller than negative 6 go to the left, so negative 7 is smaller, and negative 5 goes to the right. Because negative 6 is not included as a possible answer, because m has to be less than negative 6, we're going to use an open circle, and we're going to draw an arrow to the left to show that all of our possible solutions have to be smaller than negative 6, and every number to the left of negative 6 is less than negative 6. Now we're going to look at some special situations where we have negative coefficients. So we're still going to follow that same process of solving these inequalities, so we'll start by drawing some lines. We're going to subtract 5 from both sides, and we're left with negative 4b is greater than 20. To get b by itself, we're going to divide both sides by negative 4. So b is greater than negative 5. If we choose a value that's greater than negative 5, so for example 0 is greater than negative 5, we can go ahead and check. Negative 4 times 0 is 0, plus 5 is 5. 5 is not greater than 25. So we need to go through and we need to actually change our inequality symbol. So b should be less than negative 5 to make this inequality true. we can check with a solution that is less than negative 5. So for example, negative 10 is less than negative 5. Negative 4 times negative 10 is 40. 40 plus 5 is 45, which is greater than 25. The reason that we need to change our sign here is because when we think about negative values, so negative 4b, we're really calling this the opposite of 4b. And if we're looking at finding a positive b, we need to undo that. We need to make it positive by taking the opposite of everything. So anytime we multiply or divide both sides of an inequality by a negative number, like we did here, then we're going to need to flip this sign. We can graph this solution the same way that we graphed our other solutions. So draw our 3 points, negative 5, negative 6, and negative 4. Again, I'm going to use an open circle because negative 5 is not included as a possible value. And because I know that b has to be less than negative 5, we're going to draw an arrow to the left that shows all possible values of b have to be smaller than negative 5 to make this inequality true. We'll look at the same thing with this example here. We're going to add 8 to both sides, and b divided by negative 6 is less than negative 4. And we're going to multiply both sides by negative 6 to get b by itself. So b is less than 24. If we choose a value less than 24, so for example, 18 is less than 24, 18 divided by negative 6 is negative 3. Negative 3 minus 8 is negative 11, and negative 11 is not less than negative 12. It's actually greater than negative 12. So we need to flip that inequality sign to make this true. So we can pick a value greater than 24. So 30 is greater than 24. 30 divided by negative 6 is negative 5. Negative 5 minus 8 is negative 13, which is less than negative 12. So flipping that sign again makes that inequality true. When we look at why this happened, we multiplied both sides of this inequality by a negative number, causing us to need to flip that sign. Again, this is asking us to do the opposite when we deal with a negative value. Again, we're going to graph our solution the same way. 24, 23, and 25. And because 24 is not included as a possible value, I'll use an open circle. And to show that all values of b must be greater than 24, we are going to draw an arrow to the right. So as a general rule of thumb, anytime you multiply or divide both sides of an inequality by a negative number, you must flip that inequality symbol to make that statement true. I want to clarify one other thing. When we look at example 2 from both of these problems, we did multiply by a negative number up here. There was negative 3 times 2. However, the difference is that in this example, we multiplied both sides by a positive number, whereas in this example, we multiplied both sides by a negative number. So when you follow these rules for flipping the sign, you need to make sure that you are multiplying or dividing both sides of that inequality by a negative number, not just one side as we did here. Hopefully that clarifies any confusion that you may have had and gives you some good information. Look forward to seeing you guys in class.